Alright, back with question 8. This is IB SL Maths, paper 2, time zone 2, May 2015 paper. Question 8, start of section B, answer all questions, blah blah blah. Two functions, f of x, g of x, part of them are shown in the diagram. They intersect at the point P, which has coordinates PQ. Find the value of P and Q. What are we going to do? We're going to use our calculators, aren't we? So we get our calculators out. Here I have the functions. 9 divided by x plus 2, that's f of x. 3x squared, that's g of x. Set up your viewing window. So that's 0 to 10. Yep, that looks like it'll be about right. We're squaring something here in g of x, so I think going up to around 30 is reasonable. May or may not be, we'll have a look at it. Doesn't really matter, but if I go, oh, we're done there, so I exit and have a look at my thing. Well, it's not identical, but it's good enough, and we can see where they intersect. That's what we're after. Shift G solve, graphically solve. Where do they intersect? And they intersect at the point 1, 3, so therefore P equals 1 and Q equals 3. Before that you would have said something along the lines of let f of x equal g of x, showing that you know how to solve it, and then use graphical display calculator to get P equals 1 and Q equals 3. That's enough working for your 3 marks. Pretty easy, hey. Write down f dash of P. So they obviously let you just go ahead and use your calculator to find that. I'm not going to deprive myself of the joy of finding the derivative of this. So here I've got 9x plus 2 to the negative 1. There's a chance for your chain rule, isn't it, when you find f dash of x? Derivative of the outside of the brackets, negative 1 by 9, negative 9, x plus 2 to the power of negative 2. Chain rule says you then got to multiply by the derivative of the inside, which in this case is just 1, so it's not changing it, not affecting it anyway. But that's okay. We can just make that look a little bit pretty now. So that equals negative 9 over x plus 2 all squared. That's f dash of x. They want us to find f dash of p. And we know that p is equal to 1. So we can say this is f dash of 1, which is negative 9 divided by 1 plus 2 all squared. Obviously that's 3 squared is 9. So f dash at p equals negative 1. Now we'll just go back and fill in that left-hand side there. We got that bit. Let's move on to part C. Let L be the normal to the graph of f at the point P. Find the equation of L, giving your answer in the form y equals ax plus b. So if I'm working over here, here's part C. The gradient of the tangent is negative 1. Therefore the gradient of the normal equals negative 1 over the gradient of the tangent. So the gradient of the normal is actually going to be 1. It's going to have a gradient of 1. So I've got y equals 1 times x plus c. I'm going to sub in the only point that I know on the line, which is of course 1, 3. That's where the normal will go through, therefore 3 equals 1 plus c, 2 equals c. So that implies that the equation of the normal is y equals x plus 2. So we've got y equals x plus 2. The next little part here, C part 2, says write down the y-intercept of L. So L being the normal to the graph, so that shouldn't be too hard for us to come up with. So part 2 of C, so we want to just make it really clear. The y-intercept, obviously, let x equal 0 if you want to be really sure that you get it right. Therefore, y-intercept equals 2. And again, if it asks for coordinates, you can call that the point 0, 2. It doesn't really matter. Either one would be accepted in this one. It didn't ask for coordinates, so that's fine. Finally, D. Let R be the region enclosed by the y-axis, the graph of G, and the line L. So we've got our line L over here. we've got, there's our line L, already drawn in and labelled. There's G. The area that we're after is that area in there. How do we find the area between curves? Not too bad, is it? Which one's on top? It's line L. So the area is going to be the integral from, obviously we're going from 0, that's our left-hand point, y-axis, up to where they intersect, which is an x-coordinate of 1. And it's line L, which has the equation x plus 2, minus g of x, which I think was 3x squared, wasn't it? Yes, it was. Minus 3x squared dx. So, this now just becomes a little bit of fun. You can actually do this on your calculator. It's a calculator question. So, let's exit out of that. I'm going to get rid of that first equation. Second one I'm happy enough to keep, but I'm going to enter something in before that, aren't I? I'm going to have bracket x plus 2. Oh, I didn't do plus 2, I did x22. What was I thinking? X plus 2 minus 3x squared. So 1 on top, minus 1 on the bottom. I can enter that. There it is there. Shift G solve. We want to go across and find the integral from x equals 0 is my lower bound. My upper bound is x equals 1. And there you've got it. The area equals 1.5. And again, you can just do that on your calculator there. Area equals 1.5 square units, or units squared, however you want to write it. And that'd be fine. You could, of course, go ahead and do that one by hand. That one's easy enough. That you would be able to do it by hand. So this is going to be the area equals x squared over 2 plus 2x minus x cubed. And we're going to need to sub in 1 and 0 here. So the area equals 1/2 plus 2 minus 1. And then we subtract. And each of these terms is just going to be 0 when I sub in 0. And again, you've got 2.5 minus 1. 1.5, 1.5, 3 over 2. Any of those answers are going to be fine. You obviously don't need to write all of those, you just write one of them, and you're done. That's question 8. 2 to go. See you in the next one, guys.